So we've had some practice solving inequalities. Now we're going to solve multi-step inequalities. So there's the I can statement for section 2.5. I can solve multi-step inequalities. And we're going to start with a warm-up question that has an inequality in it. So it says, which of the following numbers is a solution to this inequality right here? And then the follow-up to that is, how can you tell? So one thing that we could do with each one of these is, remember, the whole idea of solving an equation or an inequality is to get numbers that we plug in that make the inequality or the equation true. So we could plug each one of those in there and see if they actually work. That would be one way to do it. But let me show you something else that we mentioned yesterday. If we were to go ahead and solve this, so if I went ahead and solved this and I subtracted 3 from each side, and I get 2x, this would be greater than or equal to. Remember, subtracting does not change the direction of the inequality. So this is a 2, and then I'm going to divide both sides by 2. Dividing by a positive doesn't change the direction of the inequality. So we're going to get x is greater than or equal to 1. So there's the inequality that demonstrates the answer. And we could also graph this. So 0 is right here. And then I'm going to put a 1 right here. I'm going to put a 1 underneath that big open circle right there for the time being. We are going to close this in because it can actually equal that. And then let's read this from the variable. X is greater than or equal to -1, or the answers are greater than or positive 1. The answers are greater than or equal to 1. So that means we're going to shade this direction right here. Well, the cool thing about having this graph is it shows us what the answers are. It's like a picture of where the answers are. The answers are up here, they're not down here. So anything from 1 and above would be perfectly fine. So take a look. 0 is right here. 0 is not in the shaded area, so this would not work. Okay? No way on that one. 1, would it work? Okay, so if we plug in a 1 into that inequality, notice that it's shaded, so this one should work. And I'm going to do this. Let's go ahead and plug it in. This would be 2 times 1 plus 3 greater than or equal to 5. Well, that would be 5 is greater than or equal to 5, and it is equal to 5, so that would be true. That would work. And same thing would happen here. 2 would be about right here in this shaded area. So this one should also work. And if I plug that in, I'd get 4 plus 3, that would be 7. 7 is definitely bigger than 5. And just to go back and show that 0 does not work, if you plug a 0 in here, we get 2 times 0 is 0, and then 3 is greater than or equal to 5. 3 is not greater than or equal to 5, so that would not work. And then just to make sure that we've got this straight, I'm hoping that you can finish this off, because I'm going to ask this several times. You'll have a teacher in the future that will talk about solving inequalities. They'll ask you, how do you solve inequalities? You need to be able to rattle something off. So we solve inequalities just like we solve equations, except when we multiply, and I'm hoping you can kind of work ahead of me on this one, multiply, or you should know what the other one is, or divide by a negative. So we're going to do exactly the same thing when we solve an equation, except when we multiply or divide by a negative, then we switch the direction of the inequality. Now, there's some people that will say, well, you just flip the inequality or something like that. And then that's kind of true. That gets to the point. But we really want to say we switch the direction of the inequality. Okay? So we're going to solve inequalities just like we solve equations, except when we multiply or divide by a negative, then we switch the direction of the inequality. Okay, so I've got a little box right here. Solving multi-step inequalities is no more difficult than solving one-step inequalities. It does take a little bit more time and a little bit more work, but we want to keep a few things in mind. It's only when we multiply or divide both sides by a negative, then we switch the direction of the inequality. We talked about this last time. It's the step that we are taking that can switch the direction of the inequality. If there's a negative already in there, that doesn't necessarily change the direction of the inequality. So you want to think about the step that we're taking. Once we're done solving, it's usually best to read the inequality from the variable. And if the endpoint is included, so in other words, if it's a less than or equal to or greater than or equal to, if it's got that equal to bar right there, then I'm going to say this: we close in the circle. In other words, we fill it in. If it's not, if it doesn't have that, then the phrase that we use is we say we leave it open. We call it an open endpoint. Okay? And then the last point that we want to make here, and remember, is the solution to an inequality is all the numbers that make the inequality true. Okay? And that's why we shade part of the number line. The shaded part is a picture of all of the numbers that are solutions. And that's what we were talking about up here. It's very easy in this warm-up question right here to look at these and say, well, is it in the shaded area or is it not? If it is, it's an answer, it's a solution. And if it's not, then it's not. Okay? So let's run through, and the instructions here are very similar to what you're going to do on your assignment today. We're going to solve the inequality, we're going to circle our answer, and then we're going to graph our answer if a number line's provided. So you'll notice that we've only got a number line on this one right here, and the ones below there. So let's go ahead and do this one. So long fraction bar right here, that groups the two of these together. So we're going to multiply this side by 8, and we're going to multiply that side by 8. Again, we're multiplying by a positive 8, so that doesn't change the direction of the inequality, so I'm going to rewrite that. So we've got an x minus 1 over here, and we've got a negative 16. Again, it doesn't matter that this answer is negative. What matters is what we were multiplying by. We were multiplying by a positive. So then we're going to move the 1 by adding 1. Adding does not change the direction of the inequality, no matter what we add, as long as we're doing the same thing to both sides. So this is going to stay in this direction right here, and this is going to be a negative 15. That quick, we're done with the problem. Let's go ahead and graph it. We're going to put a 0 on here for reference. The most important number on this number line is a negative 15, so we're going to put a circle around it. Are we going to close it in or leave it open? We're going to leave it open. And then again, we'll read from the variable x's, or the answers are less than negative 15, so we're going to shade to the left side. So it's going to look like that, and we're done. Okay, let's take a look at the next one. Again, notice no graph, so all we're going to have to do is just solve this. So we're going to isolate the variable term here, so we're going to subtract 1 from both sides. Again, think about the step we're taking. We're just subtracting, so that doesn't change the direction of the inequality. So we've got negative r over 3 less than or equal to, this is a negative 4. Okay, we still need to get that r by itself, and let's be smart about this. They did divide by a 3, but if we just multiplied by 3, that would still leave the negative right there. So we're going to do something clever. We're going to take care of both of these at the same time. We're going to multiply by negative 3 on both sides. So negative times the negative is positive. The 3 will cancel with the 3 that we're dividing by in the original problem. Now remember, we're multiplying by a negative 3, so we're going to switch the direction of the inequality. We're going to change it that direction. So these are going to cancel, so we're going to be left with an r over here, and we get a 12. Go ahead and circle that. We don't need to graph it or anything like that. We're done with that problem right there. Let's take a look at the next one. We've got some simplifying to do right here, so let's go ahead and do that first. And again, simplifying is not solving, so that's never going to change the direction of the inequality. So we're going to have 5 plus 11x greater than negative 17. Let's see. We're done simplifying here, so let's go ahead and solve. I'm going to move that 5 to the other side by subtracting 5. Subtracting does not change the direction of the inequality. Okay, so we leave it that direction. Let's see, same sign, find the sum. This is going to be a negative 22. We're going to divide both sides by 11. Remember, we are dividing by a positive 11, so we're not going to change the direction of the inequality. We're going to leave it that direction. So we get an x over here, and on the other side we end up with a negative 22 divided by a positive 11, so we end up with a negative 2. Again, just because that turned out to be negative doesn't mean we change the direction of the inequality. We leave it just like that. That's the right answer. So here's 0. Here's negative 2. We're going to leave it open because there's no equal to, and it says x is greater than negative 2. So we are going to shade this direction right here. We're going to shade to the right. Go ahead and fill that in. We'll take a look at this next one here. We've got some distributing to do. So we've got 64. And again, we're simplifying, so that's certainly not going to change the direction of the inequality. This is going to be a negative 16n. This is what we need to isolate, that variable term there. So we're going to subtract 64 from both sides. So this is going to be a 0 on this side. Subtracting does not change the direction. So we've got this, and then we need to finish this off by getting rid of the multiplying by negative 16. So we're going to divide both sides by negative 16. And again, because we're dividing by a negative, we're going to switch the direction of the inequality. So I'm going to put the n over here. I'm going to change that to a less than if we read it from the variable, and then we've got a 0 over there. So there's our answer on that one. Again, no graphing required there. So let's take a look at this guy right here. Some simplifying here. I'm going to enlarge this just a little bit so we can kind of see what's going on here. Make sure that's big enough that I can still see the graph. Yep, we're in good shape. So we're going to distribute negative 4 and negative 20x minus 15. Again, all we're doing is simplifying. We distributed a negative 4 through, but we didn't multiply both sides by a negative. All we were doing is simplifying, so we definitely don't change the direction of the inequality. Let's combine the like terms here. So this is negative 20x. This is going to be negative 19 when we put the two of those together, and then we've got a 101 here. We're solving this right here, so we're going to add 19. Adding 19 does not change the direction of the inequality. And let's see here. So we've got 101 plus 19, that's 120. And then we're going to divide by negative 20 on both sides to get rid of that right there. Now again, the step we're taking is we are dividing by a negative 20, so we're going to change the direction of the inequality. Positive divided by a negative is negative. 120 divided by 20, you can double check that on your calculator. That's going to be a 6. So there's our answer. Let's go ahead and graph this answer and see what we've got here. So 0 is going to be here. I'm going to put a circle for negative 6. I'm going to label that. Are we going to close it in, or are we going to leave it open? We're going to go ahead and close this in because it says it can actually equal that. And then let's read from the variable. X is on the small side. It's less than or equal to negative 6. So we're going to shade this direction right here. So we're all set with that one. So we got that one finished up. Got good shape there. I'm going to slide over and we're going to take care of this last one. Okay, again, some simplifying to do here. Those are like terms. So we have a 2n and a plus 6. And simplifying is never going to change the direction of the inequality. I'm going to move the smallest one. Now this is a big deal when we're solving inequalities, because if we move the smallest one, that's going to mean we have a positive coefficient here, and that's going to help us. Remember, we have to deal with negatives when we multiply or divide with inequalities, so we want to avoid that when possible. So we're going to get rid of this one from this side. Let's go ahead and move the negative 6 to the other side. So let's add 6 to both sides. Again, all I've done here is I've subtracted 2n from both sides and added 6 to both sides. Adding and subtracting never change the direction of the inequality, so we can leave it this direction right here. This is a 12, and this would be 6n minus 2n is a 4n. Now we're going to divide by 4. And notice that we're dividing by a positive 4, so that's not going to change the direction of the inequality. 12 divided by 4 is 3. So there's the answer to that one right there. So there are the solutions that we've got there. That's our first crack at solving multi-step inequalities. Should be very similar to the ones on your assignment. Good luck with that.